Hello and welcome back. In the previous lesson, we learned about row and column store in SAP HANA. In this lesson, we will discuss about other key features of SAP HANA, such as data compression, partitioning, and parallel processing, and aggregates and indexes. We know that SAP HANA is an in-memory database, and it always tries to place entire database in main memory. SAP HANA can achieve this because of its automatic data compression ability, which reduces the database's data footprint to a fraction of the original data size. SAP HANA uses different efficient compression methods such as dictionary encoding, run length encoding, and more to compress the data. In the next slide, we will understand SAP HANA's data compression mechanism using a dictionary encoding technique. Data compression is most effective when there is a lot of repetitive data values. For each data compression, each unique value is stored in a dictionary store. For example, for the sales order table, we have a dictionary store for all unique customers. SAP HANA then uses integers to represent the business values in the original store, as this takes far less space and is very efficient for scanning, as you can see in the compressed column. SAP HANA links the dictionary table entries to the actual table using reference stores. These reference stores index the position of the original values with its corresponding business value from the dictionary store. This mechanics is embedded deep in the SAP HANA database. The processing happens invisibly and we get a highly compressed data. Let's now understand partitioning and parallel processing. In SAP HANA, due to column storage, the data is partially blocked. This makes parallel processing easily achievable. The data of different columns are made available to different CPU cores. To achieve still further parallel processing, the same column data can be split and made available to different CPU cores for parallel processing. The data can also be partitioned further and made available to several blades, leading to still advanced parallel processing. One of the key enablers of SAP HANA's incredible performance is parallel processing, and it is also the key enabler for real-time processing for any application powered by SAP HANA. Let's now understand the concept of aggregates and indexes with respect to SAP HANA. Another key feature of SAP HANA database is aggregates and indexes. In traditional databases, it was common practice to have aggregate layers on top of detailed data to help application performance. Plus, on top of aggregates, we built more aggregates and special versions of the database tables to support special applications. This all led to storing extra data as well as more application code to maintain aggregated tables. Moreover, database indexes were created to speed access to data. The database indexes then need to be constantly dropped and rebuilt each time the tables were updated. So again, more code required to maintain this complex indexing. SAP HANA eliminates all these problems by having no aggregates, less indices, and less application code lines. Using the power of SAP HANA, you can aggregate on the fly from any line item table. You do not need pre-built aggregates. SAP HANA can generate any view of the data at runtime, all from the same source tables. SAP HANA organizes data using column store, which means that indexes are not needed. They can still be created, but they offer very little improvement. As well as removing the aggregates and indexes from the database, you can also remove huge amounts of application code that deals with aggregates and indexes. So you are left with a very simplified core data model as well as simplified application code. It is much easier now to enhance the applications and integrate additional functionalities. That's all in this lesson. Thanks for your attention and see you in the next lesson. If you like this video, then don't forget to subscribe and hit the bell icon.